Good morning, everyone, and welcome to the June Pacific Northwest Drought Early Warning System Drought and Climate Outlook webinar. Thank you for joining us. My name is Megan Dalton, and I'm with the Pacific Northwest Climate Impacts Research Consortium, or CIRC. This bi-monthly webinar series is hosted by NIDIS, CIRC, and the Northwest Climate Hub. It is designed to provide stakeholders in the Pacific Northwest with timely drought and climate information. Each webinar is tailored to reflect recent, current, and forecasted conditions and climatic events, and also includes discussions of observed impacts and other relevant updates from across the region. Just to note, this webinar is being recorded, and the recording will be posted on drought.gov later this week. And after today's webinar, you will have an opportunity to provide feedback that will help us improve the webinar series. So please take a moment and tell us what you think. Today's speakers include Larry O'Neill, Director of the Oregon Climate Service, who will present the climate recap and current conditions. Then Brett Lutz and Misty Furman with the National Weather Service Medford Forecast Office will present the climate outlook. And then next we have Vincent Jansen from the University of Idaho, who will demonstrate the satellite-based assessment tools for rangelands. And finally, Brian Henry with the National Interagency Fire Center will present the wildland fire potential outlook. During the webinar, please use the chat box to ask questions during the presentations, and we will address them at the end of all speakers during a Q&A period. If we have time in between speakers, we may take a question or two. And before we move into the presentations, we'll briefly highlight the partners that make the webinar series happen. So first, here's the Pacific Northwest Climate Impacts Consortium, or CIRC. It's a climate science to climate action team funded by NOAA's Regional Integrated Sciences and Assessment Program. CIRC supports communities, policymakers, and resource managers in Oregon, Washington, Idaho, and Western Montana as they work to adapt to the changing climate. The Northwest Climate Hub develops and delivers science-based region-specific technologies and practical information that will assist agricultural and natural resource managers with climate-informed decision-making. And I'll turn it over to Britt Parker to highlight NIDIS.
Thank you, Megan. NIDIS's mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. We want to improve our understanding of how and why droughts affect society, the economy, and the environment, and to improve accessibility, dissemination, and use of early warning information for drought risk management. NIDIS's approach to achieve that goal is to build the foundation of a national DEWS through the development of regional DEWS, where networks of partners and stakeholders share information and actions that help communities cope with drought. While the ultimate goal is a national early warning system, we recognize that the impacts and early warning information differ across the regions. Each DEWS has many of the same base ingredients, but ultimately have their own flavor to reflect the needs of their region. The Pacific Northwest DEWS was officially launched in February 2016, and our strategic plan is available on drought.gov, with an updated plan being released soon. This roadmap for moving forward with the DEWS identifies existing and new drought-related activities in the region to build drought early warning and preparedness. So please mark your calendars. Our next Pacific Northwest DEWS Drought and Climate Outlook webinar is August 24th of this year. Registration information for these and other webinars can be found on drought.gov. And before I turn it over to our first speaker, I want to talk a little bit about CoCoRaHS. To facilitate our early warning system, more precipitation observations are needed. We encourage you to join CoCoRaHS, the Community Collaborative Rain, Hail, and Snow Network. This is a unique, nonprofit, community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, rain, hail, and snow, as well as condition reporting. Observation by CoCoRaHS observers of precipitation events or the lack of precipitation are important to capture and improve our understanding of regional weather. And here are your CocoRa's coordinators if you're interested in getting involved. And Heidi will also put these contact information in the chat box if you're interested in learning more. Thank you.
All right, thanks, Britt. So next we'll move on to the climate recap with Larry O'Neill.
All right, thank you for the introduction. Okay, am I ready?
Looks good, Larry.
Okay, thanks. All right, thank you for joining, everyone. So my name is Larry O'Neill, and I started last year as the state climatologist of Oregon, and I'm currently housed at Oregon State University. And today we're going to talk about drought and climate outlook and the recap and current conditions for spring of 2020, approximately from April to June. And I just wanted to list a couple of significant events that we've encountered the last few months in the Pacific Northwest. Probably one of the big headlines is the drought conditions that we're experiencing, particularly in Oregon and Central Washington and Southern Idaho. We had a bit of spring heat in late April, early May. We've had some good amounts of spring rainfall that have been widespread over the region that have really it's been a welcome sight for sure. Some of the exciting weather, we had late May thunderstorms, including some supercells and some very heavy convective rain events in some critical areas that needed rain. And finally, I wanted to just highlight that we had an unusually early snow meltouts in the Cascades, particularly in Southern Idaho and Oregon. And so we start with the conditions where we kind of came into April with, and so this is the US Drought Monitor for the US West. And you can see that over quite a bit of our region, we had regions that are experiencing at least some drought conditions, the maximum being kind of D2 in the Southwest Oregon and the Klamath River Basin, and then also in north central Oregon and Washington as well. And the nice region in the Klamath Basin somehow took on the shape of a nice swan, and it was completely unintentional, but longtime viewers of Drought Monitor will kind of recognize that shape. And so fast forward to this week's current conditions, and basically drought severity increased in Oregon and central Washington, and we had some introduction of D2 drought in southwest Montana, and also introduction of D3, which is extreme drought in parts of central Oregon and down in southwest Oregon as well. And so we've been watching those regions very closely. But overall, the picture, we have not increased the drought coverage at all between this time. And so if you just want current conditions for how much of these 4-state region is in drought, right now 16% is in moderate drought, 13% in severe drought, and a little over 1% in extreme drought. And very fortunately, about 37.6% is completely drought-free. So that is that's good news there. And just looking back at the time series of drought coverage over the Pacific Northwest over the last 2 years, going back to January 2018, this time series shows just the various drought categories of the Drought Monitor from D3, D2, D1, and D0, and then D nada. And so right now we're kind of on track, similar to aerial coverage of 2018. Although I should note that this year we had an earlier appearance of D2 in Oregon and South Central Washington. So that kind of distinguishes this drought this year, and it's kind of is an indication of the very poor conditions that we experienced in the fall, where we had very little rain. So for the last 60 days, I just want to give an update. In most locations, we received more precipitation than normal, which was very lucky. And this map shows just the ranking compared to climatology of the rain that we experienced. Many regions were above normal, as shown by the green colors in the top third of years. And then in northeastern Oregon and eastern Washington, it was actually fairly significant, about in the top 10% of rankings. And then we have some encroaching dryness from the east that has taken hold in the Snake River Basin and in central and western or eastern Montana as well. And so while the that might paint a picture that you know, the drought is improving, that the rains improve the drought significantly. If you take a look at the broader picture of the water year to date precipitation, we've actually been quite challenged this year as far as the rainfall, and a lot of this had to do with the extremely dry fall that we've had and some other dry periods in the late winter and early spring. So this map shows the total precipitation anomaly since October 1st, so encompassing the full water year. And the brown colors indicate drier than normal conditions, and the greener colors show wetter than normal conditions. And the areas that stand out mostly that I want to just point out are central Washington, central Oregon. So this is kind of the east side of the Cascades. The rain shadow effect this year appears to be quite significant. And then also in the Snake River Plain in central Idaho, and then in southwest Oregon as well. Here, areas that actually were received pretty good precipitation include the Owyhee Mountains in Idaho, the Wallowas in northeast Oregon, and then the near the Puget Sound in Washington as well. So if we want to rank this, the water year in terms of you know, in terms of climatology, this shows just the kind of just general ranking of the water year so far in the northwestern United States. So yellow and red colors show drier than normal, and then the green colors show wetter than normal. And the area that really stands out is, of course, north central and south central Washington, where, at least according to this data set, this is one of the driest water years on record. And then in much of western Oregon, we're in the bottom third or bottom 10% of water year as well. And then also in the Snake River Plain in Idaho as well. And just a quick look at the soil moisture. So this is a soil moisture estimate. So this shows percentiles as well, just to see where we are currently ranking in terms of soil moisture. And of course, the region where we've been most, the regions where we had the least amount of precipitation, you know, again, south central Washington, north central Oregon, and central Idaho here. We have received pretty good precipitation along the Cascades and snow melt right now, so that's kind of momentarily boosting soil moisture supplies there. And then the Wallowas have actually been quite good this year, following a couple of the wintertime extreme rain events that they received. As far as 60-day service air temperature anomalies, the Pacific Northwest, for the most part, has been warmer than normal, except parts of northern and eastern Washington. And so the region has been somewhere on the order of about 0.5 degree to 2 degrees Fahrenheit warmer than normal, taken into account. Something interesting, though, is that the maximum and minimum temperature shows quite an interesting pattern. So the maximum daily temperature anomalies, this is the high temperature anomalies, shows that it's actually been quite a bit colder than normal in northern Washington and much of Idaho and western Montana, and also in the Willamette Valley in Oregon. It's been warmer than normal out in the desert regions of southeast Oregon. Minimum temperature actually shows that uniformly, almost throughout the region, we've been warmer than normal daytime low temperatures. So it's kind of an interesting contrast there. And I want to look at the snow water equivalent. This is what we entered in April 1st, the percent of mean by basin throughout the Pacific Northwest. And you can see that across the northern and eastern part of our region, with the exception of the upper Columbia Basin, we've gotten a little bit above average snow. And then Willamette Valley, we eked out exactly 100% of average in the Willamette Basin. And then in southern Oregon, southwestern Oregon, we had a little bit less than normal, particularly in the Klamath River Basin there. When we got to May 1st, the situation changed dramatically. We had a warm event in near the end of April over a couple weeks, and we had very rapid snowmelt kind of throughout the region, particularly in the southern regions. And then when we get to June 1st, there's kind of continued that trend, and right now kind of northern Idaho and western Montana are the ones that are closest to the average that we have right now. And then currently the trend is continued as well. And just to show 2 examples of the rapid snowmelt in Oregon, the left-hand panel shows a time series of the Willamette Basin snow water equivalent index. The red shows the current time series progression through the water year. The dashed line is the average, and then the percentiles of previous distributions are shown. And so on April 1st, we were near average, and then as we got into May, the declination of the snowpack was very rapid, and so we had meltouts here about 2 to 3 weeks early, and this also story unfolded in the Klamath Basin as well here. And you can see this in the 28-day streamflow as we came into April. The red colors here show that the streamflows were very low compared to historical standards all throughout Western Oregon and Washington. And then with the combination of the rapid snowmelt and the spring rain that we received, we got much better stream flows here. We still have some issues in the Snake River Basin with low flows at this time of year. And if you want to take a broader look at the runoff percentiles in the stream flows, so this just shows the percentiles of runoff. And so reds and oranges indicate below normal for April to May. And so in Oregon, particularly, and then the Snake River Plain in Idaho, the runoff percentiles have been quite lower than normal. And everywhere else, most of the places look fairly good. If you look at the water year to date, however, you could see you could pick out the drought regions very well. And particularly in Oregon, we're down at the somewhere around the 10 to 30th percentile as far as seasonal runoff has gone. And this is also true in Idaho as well. So the very quick summary is the last 2 months have seen quite varied conditions across the Pacific Northwest, and it's ranged from wet to very dry, and it's been mostly warmer than normal. Drought coverage remained mostly unchanged, but the drought severity worsened in places. The real story here is an unusually quick melt out of mountain snow in many places, and in Oregon and southern Idaho. And whilst current stream flow is mainly within normal range throughout most of the basin, runoff has been quite low, and we expect that stream flow in the next coming months we'll be missing the snowmelt component. And finally, the $1,000 question is spring rains have provided some short-term improvement in hydrologic conditions in many places in the Pacific Northwest, but it did not really appreciably improve our wet season precipitation deficits that we accrued. And so we expect this to be a problem going forward. So thank you.
Thank you, Larry. Next, we'll move on to the climate outlook with Brett Lutz and Misty Furman from the Medford Forecast Office.
Looks like Misty may have dropped off. Not seeing. Oops, yeah.
Should we? Oh, here it looks like she's coming back.
Okay, she's going green.
Okay, how about now?
We can hear you, Misty.
Okay, sorry about that, guys. All right, so one more time, my name's Misty Furman, and I'm here with Brett Lutz. We're both forecasters and climate focal points at the Weather Service here in Medford. So first we'll be taking a look at the current conditions of ENSO, the El Nino Southern Oscillation, provided by the Climate Prediction Center. So currently ENSO neutral conditions are present. Sea surface temperatures across the equator are near to below average across the central and eastern Pacific. Also, the tropical atmospheric circulation is consistent with the neutral phase of ENSO. All right, these conditions have remained fairly consistent over the last 4 weeks, including above average anomalies in the Western Pacific. A look at the subsurface temperatures show that warm anomalies peaked during October 2019 and again during January, February of this year. These anomalies weakened and returned to zero in March, and then the anomalies then became negative and strengthened during April and early May. A look at the sea surface temperature trends pictured on the left here shows that during the last 4 weeks, negative sea surface temperature anomalies have strengthened in the east central equatorial Pacific. In addition, negative subsurface temperature anomalies pictured on the right have strengthened as well and shifted eastward from the western Pacific Ocean. In the meantime, positive anomalies have mostly dissipated. So what do the models have to say regarding which phase ENSO will transition to? We're finally moving away from the spring barrier, so there's a little more reliability in the model predictions than during the springtime. The image on the left shows what the couple forecast model is predicting. Looking at the black dash line, which is the ensemble mean, the CFS predicts ENSO neutral to continue through the summer, then favors La Niña thereafter. The graphic on the right shows various model predictions provided by Columbia University's International Research Institute for Climate and Society, and the majority of these models favor ENSO neutral through summer as well as fall. However, the latest run from this month has shown a trend towards more negative values. So here's the official forecast from CPC. If we focus on the bars on the left image, ENSO neutral is most likely to continue through the summer. Then it looks like equal chances, about 40 to 50% chance of ENSO neutral or La Niña during the fall or winter. According to Emily Becker in the most recent ENSO blog, there's a strong correlation between the May subsurface temperature and the October, November, December oceanic index. So if we're looking at the graph here on the right, negative May values correlate to La Niña, while positive values correlate to El Nino. This May 2020, was negative 9.2 degrees Celsius for the subsurface temperature. This would suggest the odds would lean toward La Niña. However, there was one instance where May's subsurface value was similar to this year's, and then neutral conditions occurred during the October, November, December season. So time will tell. Here's a look at the typical wintertime pattern under La Niña conditions, should odds go that way. It would certainly be beneficial for drought purposes here, should this pan out. However, we still have the rest of summer and fall to get through. So with that, I will pass it to Brett to talk about the seasonal outlooks.
Okay, so yes, as Misty said, my name is Brett Lutz. I'm a lead forecaster here, also an incident meteorologist and the fire program manager. I wanted to start off by showing you a outlook, a link to an outlook on our webpage for monthly climate summaries and a 1-month outlook that Misty and I have been doing since 2016. Basically, what we do here with this outlook is we start with CPC, the Climate Prediction Center's 1-month outlook, and then we basically try to provide more detail in terms of timing and magnitude of the anomalies based on ensemble data, so ensemble models, and also 1-month seasonal models that we have access to. So, for example, here, what you'll notice is that, the forecast is pretty consistent with CPC's forecast, and that's pretty common. And we were really focusing on areas west of the Cascades as where it was most likely to be wet. We also talk about potential impacts. So if there's a heat wave coming, we're trying to fine tune that and talk about that in advance so that fire partners and whatnot can be ready for it when it comes. So looking at the 1 month June drought outlook, this was obviously made at the end of May. What we notice here is that really, as Larry said, the drought persisted where it already was. While we saw some improvements and downgrades in terms of individual areas, the general drought area remained. Just looking at the 10-day stream flow forecast from the Northwest River Forecast Center out of Portland, we noticed that the only places that we're seeing basically elevated flows of some concern is up in the northern Rockies, where we saw the wetter snowpack, and also we've had some late season precipitation. Looking at the forecast for the month of July from the Climate Prediction Center issued last Thursday, what's notable is the increased probabilities of above average temperatures. And if you look here on the right, you'll notice that precipitation is really equal chances, except in the far eastern portion of the area. I do want to point out that we are looking at, the models have really been indicating a trough developing over the west and Pacific Northwest during the first week of July. And models like the CFS V2 are trending toward neutral temperatures over the Pacific Northwest for the month of July. So, that's something, a recent trend that I know CPC, Climate Prediction Center, will be looking at and we'll be keeping an eye on as well for July. Looking at the seasonal forecast, there is a greater probability of above average temperatures for this period, and also increased probabilities of below average precipitation for these core summer months. Stream flows altogether, again, from the Northwest RFC, this is stream volume forecast for the entire April through September period. And, something to point out, according to the RFC, for a lot of areas, the majority of the stream flow has already happened just based on climatology. But, this graphic is really kind of a reflection of the current water situation, in terms of what runoff is expected based on precipitation and temperatures. And so we'll move on from that. Now, shifting gears a little bit, some local research here in the Medford forecast area about fires indicates that here on the left, we have human-caused fires, 13,170, and then on the right side, you have lightning-caused fires. So you see, for our forecast area, and I think this is generally true for the Pacific Northwest, the majority of fires tend to be lightning-caused. If we look at acreage, so this graphic, this is for the same 33-year period from 1992 to 2015, what you'll note is that it's almost 7 times more acreage has been burned by lightning fires than human-caused fires. We have 2 forecasters here, Shad Keene and Charles Smith, who have been really putting together a lot of lightning-related climo for us. And here we are with a pretty complex map, but you have years on the left, and you have number of lightning strikes going in the horizontal, and you see fire season. And what we're identifying here is basically where are the big events, because once it's dry during fire season, it's the magnitude of the lightning that causes an abundance of fires. And so there's some recent research that we're doing related to that to try to better hone in on fire season. Of course, if we could predict lightning in advance, that would be greatly beneficial, because there are many factors that modulate fire season, and most of these we can't predict beyond a 1-month lead time. Now, the preceding dryness is something we can predict. Lightning abundance, not really. Timing and duration, magnitude of heat waves and rain, we get some of that, but really we're looking at lead times of 3 to 4 weeks most of the time. Overnight relative humidity recoveries, where fire activity doesn't diminish, is another factor, and timing and duration of wind events are also critical. So really you look at all these factors, and the quality of the forecast as well as the availability of firefighting resources is really what plays into whether or not fires get big and problematic, and you can't predict these things too far in advance. So summarizing our weather and climate portion here, we're excited about the possibility of La Nina for this next winter season. However, right now, the chances are pretty equal in terms of ENSO neutral and La Nina going into the fall and winter. May and June have provided some relief, as Larry was indicating, albeit, really surface water and brief. Outlooks were helpful in anticipating June's reprieve, but there is pretty high confidence that July, August, and September combined are more likely to end up on the hotter and drier side of climatology. Stream flows have pretty much peaked. We're seeing the end of the peak runoffs, and with lightning being the primary fire cause in the Pacific Northwest, and that's what we're really looking at here at the Weather Service is the dryness is virtually inevitable, but then it's the lightning that we really have to be looking out for. So with that, thank you very much, and we'll move on.
Thank you, Brett and Misty. Next, we'll turn to Vincent Jansen to talk to us about RangeSAT.
Hello, my name is Vincent Jansen, and I'm a postdoc working at the University of Idaho. Today I'll present RangeSAT, which is a web-based tool that me and my collaborators have been working on for a few years now. This work has been supported by the Nature Conservancy and Northwest Climate Hub grant, and more recently an NRCS Conservation Innovation grant. So what is RangeSAT? Simply, it's a set of web-based tools that provide ranchers and rangeland managers estimates of biomass across their management unit or ranch. RangeSAT does this by transforming Landsat data to measures of herbaceous biomass using models we've developed from field data. This tool can provide estimates of biomass about 3 weeks to a month after Landsat flies over a study area. It also provides biomass estimates across the Landsat record going back from 1984. For some tools, we also draw on climate data to help provide more context to the observed fluctuations in vegetation amount across the ranch. Currently, the study areas for this tool are the Zumwalt Prairie in Northeast Oregon and select locations in the Sagebrush Steppe in Southern Idaho. So why create RangeSAT? We started this project for two main reasons. The first main reason was to more accurately assess how livestock impact vegetation across large areas and over time. Field-based estimates oftentimes fall short because they only provide data at a given sample site at one moment in time. They also fail to provide an understanding of grazing between monitoring points, which is important due to the extensive nature of rangeland systems. There's a lot of area in between sampling points, as seen on the map, as well as the pictures above. The other main reason was to provide more accurate information to help guide grazing management. For example, how many cows should we put in a pasture and for how long? When to graze, as well as locate areas which may be more resilient or sensitive to grazing. In general, this information is needed because the amount of vegetation and forage can be highly variable across the landscape, but also, and maybe more importantly, from one year to the next due to weather and the underlying climate. As climate continues to change, management ideally can adapt to these changing conditions, both in the long term as well as in shorter term and the variable conditions that are presented. RangeSAT provides more information needed to both assess grazing practices, but also prescribe grazing practices, with the goal to ensure sustainable grass production and rancher income, as well as suitable habitat for biodiversity. So a bit more about how we are using satellite data to provide estimates of biomass. The approach to date has been we go out and we collect traditional field data metrics on above ground biomass as well as vegetation cover. We do this both in the summer as well as in the fall. We then extract the satellite data co-located to those in-field plots and build an algorithm that lets us estimate biomass over the growing season as well as across our study areas. From these algorithms, we can then map biomass amount and create estimates at the pixel, pasture, and ranch scale for management. So the results figure there on our right is showing you the amount of biomass across the 2016 grazing season for 3 different pastures with different management. Each circle on the graph represents the average biomass each pasture had for a specific date that the Landsat satellite flew over. The circles in the pasture in green are representing a pasture that is not grazed for the 2016 season, while the circles in pasture in red are showing a pasture that wasn't grazed and then burned in the fall. And then the circles in pasture in yellow are showing a pasture that has been heavily grazed for multiple years in a row. The next main step was really moving this science to a web-based tool for end users. This has been done in an iterative and a collaborative way with ranchers and land managers. We have relied on semi-structured interviews, surveys, as well as just plain conversation to guide how we visualize this data, what climate data to display along with this biomass data, as well as validate the maps we're providing ranchers in the field. For example, one thing that came out of some of the initial surveys was that ranchers didn't want their ranch biomass to be made public. Therefore, we have a user login so that their data remains private. RangeSAT is still in development, and recently our partner ranchers provided feedback on what other tools they would most like to see in RangeSAT. We're currently working on these tools and adding them to the interface. But for today, I'll step us through 4 tools that are currently in RangeSAT. I will not spend too much time because we don't have much time. Ideally, these tools are self-explanatory if you play with them at rangesat.org. For any given tool, users can analyze the amount of biomass as well as the normalized difference vegetation index, which is a measure of vegetation greenness across their ranch. So first up is our pasture averages map tool. It provides average biomass amounts at the pasture scale for any month in the selected in a selected year. It also lets users look at the ability to map the April through October average biomass amount across each pasture. So looking at the map, the pastures in blue and green colors are showing pastures with more biomass compared to the pastures in red and orange having less biomass. This map allows end users quickly see which pastures have more or less biomass comparatively to other pastures across their ranch for any given month or time period. The next map up is the pixel view map. Instead of showing data at the pasture scale, this pixel view map provides data at the 30 by 30 meter resolution that the Landsat data collects. This tool allows users to map biomass across their ranch for specific days that align with when Landsat flew over. With this tool, we limit the data set to only those days that have useful data. This means we mask out the bad data or times when there's clouds in the way, there's snow on the ground, there's smoke in the air. Users can download the geotiff of this data as well as download the figure itself. With this map, users can easily zoom into any given pasture on their ranch and see the spatial distribution of vegetation amounts at that 30 meter scale. For example, the amount of biomass in the fall in 2019 was low along the northern fence line in this B2 pasture, the last grazing season. Our third tool is our single year analysis tool. It shows how a select pasture performs for any given year compared to what is expected for that pasture. So looking at this graph, we're seeing the 2019 biomass for each month in red compared to the normal or 30-year average biomass for that same pasture in black. We're also showing the monthly precipitation totals for 2019 in brighter blue with the climatological averages or the 30-year averages in this darker blue. I should also mention that the gray areas are showing the 10th and 90th percentiles, meaning 80% of the vegetation data is falling in between that gray area. So as you can see, users can look at this graph and see how well their pastures are doing across the growing season, but also understand how much precipitation they have been receiving for any given year. The last tool I want to speak about is a multi-year average tool. This tool allows users to select a pasture, a vegetation indicator, and a date range of interest. For example, here we are showing the mean biomass in the dogleg pasture from 1984 to 2019 for the May 15th to July 15th time period. This graph helps show year-to-year fluctuations in biomass for a select time window, but it also has the ability to calculate long-term averages or more recent 5-year averages to help guide stocking decisions based on how users define the year set they are looking at, as well as the date range. While RangeSAT helps end users visualize and graph biomass on their ranch in new and important ways, one of the next steps we're working on is to integrate this information into existing management frameworks and to learn how this data is useful and how to use it in the most appropriate ways. To do this, as part of our NRCS Conservation Innovation Grant, we're working on ways to better create hybrid monitoring methods that utilize both the remotely sensed data as well as field data to assess short-term grazing monitoring. We do this with 3 levels of data: the remotely sensed data that I presented, looking at the biomass. We can also get changes in biomass using pre-satellite images and post-grazing satellite images and come up with a relative difference map. We're also collaring cows. So last year we put collars on 52 cows, which collect data every 10 minutes the cows are out there, to get a better sense of where those cows are actually using the rangeland. And then the third piece of information is field data collected on the amount of utilization that those cows are taking, how much grass the cows are taking off in the field. So by combining these 3 levels of data, we hope to do a number of things. First, we want to better validate the ability of remotely sensed data to capture grazing within the year. Second, to validate the in-field measures of utilization and create more efficient in-field sampling designs. And lastly, and more generally, create a more effective monitoring system, which incorporates both field and remotely sensed data at appropriate management scales. So the results of this work will continue to feed the development and application of RangeSAT. So in summary, RangeSAT provides end users the ability to map and graph biomass amounts and NDVI across their management unit or ranch. The building of RangeSAT has been a collaborative effort thanks to participating ranchers and land managers. As scientists, as climate continues to change, as climate change increases year-to-year variability in production and shifts in what we expect, remotely sensed data and climate data tools have a large role to play in delivering information to rangeland professionals for decision making. Using and testing the data delivered by RangeSAT within adaptive management cycles will help guide the building and use cases of RangeSAT in the future. So with that, I say thank you, and if anyone has other questions or comments, you can always email me at vjanssen@uidaho.edu. Thank you.
All right, thank you, Vincent. We'll move on to our final speaker, Brian Henry, for the wildland fire outlook.
Hey, good afternoon, everybody. Hit me at a really good time on this. I got some new information that's just come across my desk, even within the last hour, that I'd like to share with you all. So let's go ahead and jump on into this. And can everybody hear me okay?
Yes, we can hear you fine.
Okay, great, thank you. Okay, so we're looking at the factors that impact fire season across the West, and they're all kind of interrelated to each other and somewhat connected by the oceanic and atmospheric cycles like INSO, which we've heard some earlier presentations on. And so in a bad fire year for the West and Pacific Northwest, Northern Rockies, Great Basin area, generally speaking, when we look at all these different factors, they all basically get the red X, so to speak, that you see, basically showing that things are not looking good. But this year you can see, just look at this chart, this little graphic I put together, that things are actually, it's kind of a mixed bag. And so when we tend to have the really bad seasons, again, everything will be checked red X's. Good slow seasons be the green check marks. But you see we have a pretty good mix in place. So so right from the onset on this discussion, I want to point out it's probably going to be kind of a mixed bag type of fire season also, and it's going to vary regionally and even within the Pacific Northwest from what we're looking at currently. So let's start with some baseline and start looking at the fuels really quick before we actually really launch into the heart of the presentation with some of the new information that I just got. And I want to escape out of the PowerPoint really quick and to show you some new information that just came in. Now this is of the Southwest, so it's out of region. But something I wanted to point out to you is that this is a heavy crop of fine fuels that has grown this year across the Southwest, and that gets into the Great Basin and goes up through a good part of California as well, and even into southwestern parts of excuse me, of Oregon. So you're getting a pretty good crop of fine fuels out there that are now drying and curing out, and underneath this little ridge pattern is in place along the West Coast currently, you're going to see some rapid drying and curing of these fuels. And so as you go through like South Central Oregon, you're going to start to see fine fuels in the lower elevations looking kind of like this, and so you got its continuous bed of fine fuels out there to work with as we begin to enter our peak season. Now this is kind of critical because we're entering a pretty critical 2 to 3 week window where whatever weather events we have now kind of govern how busy our fire season is going to be, and of course the weather patterns play a pretty big role into that. So let me jump back into the PowerPoint to show you what's coming down the pike. Okay, so quickly rehashing over some of this, we knew that the fall was very dry. Soil moistures along the West Coast were very dry as well. We did get some recovery in the recent months though with the pattern shift that occurred, I believe in early May, I think it was. And so Washington in particular is doing a good bit better. Oregon's kind of a mixed bag. South Central Oregon is actually seeing drought expand. Snowpack though, up in the Southern Cascades was well below average, and it came off earlier than average, as opposed to the North Cascades, which had slightly above average snowpack. They kind of came off at an average to maybe ever so slightly slower than average rate. So with the high elevations losing their snow earlier than average across Oregon, that means that those fuels up there could become more receptive sooner for fire activity if the pattern were to stay dry. But we did have some wet systems, which kind of helped mitigate that as we moved into our what we call the spring factor, which is how quickly do we dry out and how quickly do we warm up. So we had a pretty friendly late spring, so to speak. So now we're into June and July. What are temperatures doing for us? And we're seeing a kind of a mixed bag there as we alternate between high pressure ridge events. They're not a particularly long duration, but still hot nonetheless, and these cooler wet patterns with troughs moving in. And so next up is what was alluded to earlier is convection, and when's it going to arrive and what are going to be the impacts from it. And we've already just talked about the fuels. Okay, so let's take a look at precipitation over the last 9 days and take it down to the last 30 days. Yes.
Oh, go ahead. We were just wondering if we were missing some slides, but here we are. Go ahead.
Okay. All right. Sorry. All right. So looking at the last 90 days as a whole, things have improved from what we were looking at 90 days ago because there were some bigger red areas of percent normal precipitation deficits across the West. That big blob over Southern California is from a big wet period they had back in April, so it's kind of skewing the data a little bit. But if you look up into the Pacific Northwest, the deficits are much less than what they were. But if you go down to the last 30 days, east slopes of the Cascades out into the Columbia Basin are areas that remain drier than average, whereas the west side of the Cascade Divide is still looking pretty moist, so that's pretty good there. And so as we move forward to the present, basically the same pattern's been in place. One thing I do want to point out in southeastern Oregon and eastern Oregon as a whole is that while we are a good bit above normal precipitation, above 200% of average, what this is probably doing for us across the eastern halves of both states is that it's probably going to grow another crop of grasses, mainly cheat grasses. So you're going to have a double crop to contend with. And those cheat grasses, for those of you who know fuels, they dry and cure out very quickly. And they're usually the first ones to become receptive. So as we get to August, keep that in the back of your minds because that could be an additional problem we have to deal with. So looking at the latest drought products that came out at the end of last week, basically showing the long-term droughts in effect, of course, across the Northwest. You got that axis of drought that extends from Northern California and through Colorado into Kansas and then south a little bit from there. But focusing on the Northwest, things are still dry there. There's still a little bit of dryness in the soils across the central portions of both states. And the wetness there on the east side of Oregon you see there, and also in the northeast corner of Washington. Again, that's probably going to promote some more grass crop growth up there that should dry out here once they can break out this active pattern we've been in. Moving on to the next one, these are actual assessments, measurements of the fuels across the country. First, I'm going to go up to the eddy map, which is basically looking at the thirst of the vegetation, or say drought stress in the vegetation. Across the Pacific Northwest, been tremendous improvement. I'll show you that on my next slide. And it's looking a lot better than it has. However, across California, it's starting to show signs of going south on you as far as the dryness goes, and I think they're going to get active there. Of course, Great Basin is remaining drought stress, and now Wyoming and Montana have entered the fray that much more. New England, yeah, it's looking bad there, but I think they've had just enough moisture to keep them out of play. So focusing in on the western fire season again, I think that we've got a little bit of time to work with. I was out doing fuels assessments yesterday up in eastern Oregon, up in the lower and higher elevations, and it seems to me like the fuels are still about 2 to 3 weeks away from them having significant fire activity, just based on my observations. Looking at the eddy map again, it's taking a look at the most recent weekly map that came out this morning. It's a bigger image, and then the one from about a month ago. And you can see how things have changed across the country, and again, Pacific Northwest looking better as a whole. Maybe a little small dry area up there just west of Walla Walla in the southeast corner of Washington. But other than that, looking pretty good right now. But if we get a ridge event up in there, this could quickly reverse itself. Precipitation over the last 48 hours, again, continue to have precip over every few days up that way. So that's keeping that progression of drying conditions at bay for now. But if we go back, look at the last 14 days, which we have already kind of discussed a little bit, again, we still have those dry spots right there through central Washington and central Oregon. And looking at the forecast for the next week, looking out from the Weather Prediction Center, most responses of purposes is going to be mostly on the drier side. I'm a little bit concerned, at least mildly concerned, about some convection that we're expecting across Oregon later tomorrow and actually into the next couple of days as the front moves across the area. But again, I think if we get fires there, I don't think they're going to get big yet. I think we got some time to work with. So looking at the outlooks from the CPC, the 8 to 14-day outlooks are in there in the upper left corner, and then the new 3-month outlooks for the July, August, September timeframe in the bottom right. And basically, the best available model data that we have to us for the next, the short term, is suggesting that we might have more trophy type pattern over the Northwest, and which could promote continuance of the pre-existing conditions, which is good news, which would basically slow down the entry into the core fire season for Oregon and Washington as a whole. So again, but our model data, I want to point out right now, is not exactly performing very well in the extended periods. It's bouncing around a lot, so there's not a lot of confidence in that, but that's what looks like will probably happen. But I want to really draw your attention down to the lower right, the 3-month outlooks that you see for the West. The new maps that came out did something very interesting. The changes are very subtle on the surface, but you can see the focus, that bullseye on the above normal temperature map there, centered over the 4 corners, kind of more so over Utah. And that's that they've actually shifted that east a little bit. And part of the reason why that's been done is that a lot of our long range models are suggesting an increasing potential for developing drought conditions pretty much along the continental divide states, going into Colorado, Wyoming, and up into Montana during this latter extended period. And that's pretty impactful to us because that coincides with the peak of the fire season in these areas. So we're a little bit concerned about that, and CPC has been really consistent on showing above normal potential for, increasing potential for below normal precipitation in those same general areas, at least just off to the north of that anyway. So that could be a little bit problematic as we head, especially into later July and August, and maybe even early September. Looking up to Alaska, in case you're curious, they're basically having a average to slightly below average season. They're getting tons of lightning up there, and they're getting a lot of fire starts, but they're also getting a lot of moisture, so that's keeping things at bay for them for now. So in summary, looking regionally, I'll start out with the Pacific Northwest. Basically, the pattern we find ourselves under currently is helping us out a good bit, although I'm thinking you'll probably start seeing southwestern Oregon entering the fire season here in the next probably week and a half, I would say. you'll start seeing more initial attack increasing and maybe even some larger fires before the end of that window. As far as your neighbors go in Northern California, probably enter at about the same time. Great Basin's already in play, but Northern Nevada's been pretty quiet. So that's been some good news there. Idaho's lagging a little bit, at least Western Idaho is, due to that precip events that we had about a week ago or so. And other areas, Alaska, they're at their seasonal peak now and probably will stay there for about 3 more weeks before they exit out of their somewhat slow season. Southwest will probably exit out probably around the 2nd week of July as the monsoon arrives. And of course, as the monsoon arrives, that means we start getting more lightning up this way and into the Pacific Northwest, which is a trigger for the fires when the fuels are receptive. And they should be receptive by the time the monsoon arrives. Looking at other regions, Northern Rockies probably will see a slower entry into the fire season, as well as snowpack came off later than average along the border with the Pacific Northwest. Although the eastern portion of the region is coming into play right now. They already got a couple of small fires popping up in south central Montana. And as things continue to dry over the coming weeks and couple months, it's going to get increasingly more active. Other areas of concern, Rocky Mountains, Wyoming, Western Colorado are very dry and are seeing an uptick in activity there. The eastern half of the U.S. is starting to look pretty good, so don't really have any concerns there. Even New England, I think, is going to be okay. So in summary, basically, we're starting to transition out June towards July, and the fine fuels are, if not fully cured, they're pretty close to it. And with these ridge events starting to increase a little bit, we'll see activity increase just like we do just about any year, not named 2019, which was really slow. So really have no real surprises or curveballs out there to present to you or anything that would be surprising from what you've already been observing. And here are the latest maps that we have. We just had our Met call, and they're thinking about pushing back some of the above normal potential towards August for the above normal type potential. And these areas that are in white up there doesn't mean they're not going to have fires, just means it's going to be normal type fire activity. So you can see how the maps progress through the fire season, with August probably being the most significant period, maybe even early September. So that's all I have. I'd be happy to entertain a question if you have any.
All right, thank you, Brian. We'll go ahead and take questions. If you have a question, please type it into either the question box or the chat box, and we have a few minutes to cover some questions. And Britt's pulling up the speaker contact information. So if we don't have time to cover your questions today, you can go ahead and reach out directly to the speakers themselves. It looks like we have one question. And the question is about British Columbia. Will British Columbia have a normal fire season?
British Columbia, right now, we're thinking, I was talking to my counterpart up there about a week ago, and he seems to think that it's going to be a slower type season across the southern part of British Columbia. However, as you get closer up towards the Yukon Territory, there is a little bit more dryness in the fuels up that way, a little bit of a low-end drought conditions. But when you compare it this year to the last several years, I think it'll be less than that.
Thank you. Next question is, when will the results of your fire season pattern analysis be available? And I think that's the question to Brett about the lightning analysis. So do we still have Brett on the line or Misty? It looks like they are not connected right now. So I encourage you to reach out to Brett or Misty using the contact information up on the screen to ask that question.
We just got back on. Sorry about
Oh,
that.
you just got back on. Okay, go ahead.
Yep.
Go ahead.
Okay, so can you repeat the question again? I just want to make sure I understood it.
Sure. Just the question is, when will the results of your fire season pattern analysis be available?
Sure. So, we're constantly looking at, the patterns, and the lightning climatology that's been developed is available for anywhere in the United States. And so if someone wants some information for their area, I believe that we can route them through the Weather Service office to get that information. Specifically for our area, what we're looking at is basically updating our outlook on a regular basis. And that 1 month outlook that we indicated, usually we update that during the first week of each month. So I'd say by the 7th of July, and just take a look at our website, and it'll be there.
All right, thank you, Brett. And thank you to all of our speakers, and thanks everyone for joining us today. Look for a recording on drought.gov later this week. And if you would like a copy of the presentations, you can email Britt Parker. Her contact information is shown there on the slide. And again, if you have additional questions, please feel free to reach out directly to the speakers. With that, please mark your calendars for the next webinar on August 24th, and we'll see you next time. Thanks, everybody.